Forces and laws of motion. Newton's second law of motion, numericals. Newton's second law of motion. Some points to note. Force value can be negative. You know that acceleration can be negative. Then, based on the formula F is equal to m into a, we can see that force can also be negative. Negative sign in force tells us that the force is acting in the direction opposite to that of the motion. Pay close attention to the questions asked. For graph-related questions, do not be confused with multiple values seen on the graph. Read the question properly and take only the necessary values. Remember, even if you see all positive values in the question, the answer need not necessarily be positive. #Let's do this. Read the question of solved example 9.1 on page 120 and understand the story and what you are asked to find out. Let's take notes from the question. M is equal to 5 kg, T is equal to 2 seconds, U is equal to 3 meters per second, V is equal to 7 meters per second. We have to find out the force. If T is equal to 5 seconds, then what is V? So, we have to find out two things. One is the force and two is the velocity. What can you do? We can find out F by using F is equal to m into V minus U upon T. Let's do that first. First, check the units. F is equal to m into V minus U upon T, which is equal to 5 into 7 minus 3 upon 2, which is equal to 10 newtons. Therefore, F is equal to 10 newtons. What next? For the same force, we recalculate for the increased time in order to get the new V. F is equal to m into V minus U upon T. Therefore, 10 is equal to 5 into V minus 3 upon 5. Therefore, 10 is equal to V minus 3. Therefore, V is equal to 13 meters per second. #Let's do this. Read the question of solved example 9.2 on page 121 and understand the story and what you are asked to find out. What do you have to do? So we have to find out which force will be greater. How can you do it? By using F is equal to m into A. We can then calculate it for each case and then compare. Quickly try it in the rough. Make sure to check the units before you start calculating. Let's do this. Read the question of solved example 9.3 on page 121 and understand the story and what you are asked to find out. What do we have to find out? The force required to stop a moving car. What do you know? U, T, V and M. How will you find F? F is equal to m into V minus U upon T. Quickly try it in the rough. Make sure to check the units before you start calculating. Let's do this. Read the question of solved example 9.4 on page 121. Understand the story and what you're asked to find out. What do you have to find out? You have to find the final acceleration by a certain force on a combined mass m1 plus m2. What do you know? The force and acceleration on m1 and m2. 5 is equal to m1 into 10 and 5 is equal to m2 into 20. So, we can find the value of m1 and m2. Then, we can get m1 plus m2. Then, for the same F, we can get the acceleration of the combined m1 plus m2. Quickly try it in the rough. Make sure to check the units before you start calculating. Let's do this. Read the question of solved example 9.5 on page 121 and understand the story and what you are asked to find out. What do you have to find out? You have to find the force needed. What do you know? U, V, T and M. So how can you find F? F is equal to M into V minus U upon T. Quickly try it in the rough. Make sure to check the units before you start calculating. Read the question A1 on page 130. Understand the story and what you're asked to find out. What do you have to find out? The nature of acceleration, the nature of forces. What is given? The distance at various times. How will you do this? Calculate the acceleration at different times and see what's going on. What formula will you use? S is equal to ut plus half into at square. When t is equal to 0, s is equal to 0. So, it means the object is starting from rest. So, u is equal to 0 meters per second. S is equal to ut plus half at square. When u is equal to 0, we get s is equal to half at square. Therefore, a is equal to 2s upon t square. Find a at different times. A1 is equal to 2s upon t square, which is equal to 2 into 1 upon 1 square, which is equal to 2 meters per second square. A3 is equal to 2s upon t square, which is equal to 2 into 27 upon 3 square, which is equal to 6 meters per second square. A5 is equal to 2s upon t square, which is equal to 2 into 125 upon 5 square, which is equal to 10 meters per second square. A7 is equal to 2s upon t square, which is equal to 2 into 343 upon 7 square, which is equal to 14 meters per second square. So, the acceleration is going on increasing. An unbalanced force is acting on the object. Read the question A2 on page 130. Understand the story and what you're asked to find out. What do you have to find out? The force applied by each person to push the motor car. What is given? M and A, and that each person applies the same amount of force. How will you do this? Find F and then divide it among the 3 people equally. What formula will you use? F is equal to M into A. We are given 3 people are pushing the motor car. M is equal to 1200 kgs. A is equal to 0.2 meters per second square. We have to find the force of each person. F is equal to M into A. Check all units first. F is equal to 1200 into 0.2, which is equal to 240 newtons. This is the force applied by 3 people together. Therefore, force of one person is equal to 240 divided by 3, which is equal to 80 newtons. Therefore, each person pushes the motor car with 80 newtons force. Read the question A4 on page 130. Understand the story and what you're asked to find out. What do you have to find out? Acceleration A, change in momentum triangle P, and force F. What is given? M, U, V and T. How will you do this? Using U, V, T, find A. Triangle PF is equal to MV minus MU. Therefore, F is equal to MA. We are given M is equal to 1200 kgs, U is equal to 90 km per hour, V is equal to 18 km per hour, T is equal to 4 seconds. We have to find A and F and triangle P. Check all units first. U is equal to 90 km per hour, which is equal to 90 into 1000 upon 60 into 60 meters per second, which is equal to 25 meters per second. V is equal to 18 kilometers per hour, which is equal to 18 into 1000 upon 60 into 60 meters per second, which is equal to 5 meters per second. A is equal to V minus U upon T, which is equal to 5 minus 25 upon 4, which is equal to minus 20 upon 4, which is equal to minus 5 meters per second square. F is equal to M into A, which is equal to 1200 into 5, which is equal to 6000 newtons. Triangle P is equal to MV minus MU, which is equal to M into brackets V minus U, which is equal to 1200 into brackets 5 minus 25, which is equal to 1200 into minus 20, which is equal to minus 24,000 kg meters per second. Write the answer in statement form.
If you like our videos, do share them and subscribe to our channel. If you want awesome quizzes, write to us. Keep watching and keep learning with Walnut.